Case study 1, index number. Question A. Calculate the simple relative price index for each of three items. And what can you infer from the data value of relative price index? So the fragrant rice, the current period is 9 ringgit and 50 cents divided by the past period, which is the 8 ringgit and 70 cents, and times with 100, and we get the price index, which is 109.20. The price of fragrant rice in 2023 is increased by 9.20% compared to 2022. So for the wheat flour, the current period is 3.20 and the past period is 2 ringgit and 80 cents times with 100 and the price index is 114.29. So the price of wheat flour in 2023 is increased by 14.29% compared to 2022. For the last item, the current period is 2 ringgit and 60 cents divided by the past period, which is 2 ringgit and 10 cents times with 100 and get the price index, which is 123.81. So the price of vermicelli in 2023 is increased by 23.81% compared to 2022.
Now we are going to examine the changes in price and quantity for three essential grocery items, and those are fragrant rice, wet flour, and vermicelli that is being sold at Chai Guan Mini Market between 2022 and 2023. By using the simple relative quantity index formula, open bracket, quantity in 2023 over quantity in 2022, close bracket, times 100, we can evaluate how the demand for each item has shifted over the year. Fragrant rice show a decrease in quantity sold with an index of 80, while vermicelli increased to 130.43. The most significant rise is seen in wet flour, which recorded an index of 135. This indicates that wet flour had the highest increase in demand in 2023, making it the most popular item among the three during that period.
Question C. Calculate the simple aggregate quantity index and simple aggregate price index for the year 2023 for the three items using 2022 as the base year. To calculate a simple aggregate quantity index, we can divide the sum of all quantities in 2023 by the sum of all quantities in 2022 and multiply by 100. We got 122 and 22. To calculate a simple aggregate price index, we can divide the sum of all price in 2023 by the sum of all price in 2022 and multiply by 100, we got 112 and 50. Question D. Calculate the simple average price index in 2023 for the three items using 2022 as the base year. To calculate the simple average price index, compute all the simple relative price index for each of three items in 2023 and then divide by the number of item which is 3 and multiply by 100. We got 115.77. So the price in 2023 is increased by 15.77% compared to 2022.
Case study 2, probability question 1A. Present the above information in a tree diagram with all probability values. So from the question, there are three information. The first one is 80% of customers make cashless payment. So from here, we can find the customers that made non-cashless payment, which is 20%. Other than that, we know that 75% use cashless payment for grocery item. We can find that for the non-groceries is 25%. Lastly, 40% pay in cash for non-grocery items for the customers that made cashless payment. So from here, we can find that for the customers that made non-cashless payment for the grocery item is 60%. Question 1B. What is the probability that a randomly selected customers make a grocery purchase? So the probability of groceries purchase is equals to probability of cashless intersect with groceries plus with probability of non-cashless intersect with groceries. So we get 0.60 plus with 0.12 equals to 0.72. For question 1C, what is the probability that a customer uses cash to purchase non-groceries items? So the probability is non-cashless intersect with non-groceries. So 0.20 times with 0.40, we get 0.08. For question 1D, given that the customers made grocery purchase, what is the probability that they use cashless payment? So the probability of cashless for groceries is probability of cashless intersect with groceries divided by probability of groceries. So we get 0.60 divided by 0.72. So the value is 0.8333 or 83.33%.
So now we are heading to the case study 2 probability, where we analyze student involvement in two popular sports, football and basketball, using set theory and probability concept. The study was conducted in a school through a survey involving 150 students to find out how many played football, played basketball, and how many participate in both sports. The results were as follows: 70 students play football, 55 students play basketball, and 30 students play both football and basketball. We define F as the set of students who play football and B as the set of students who play basketball. Next, we will break down the data into set components. We are going to calculate how many students play only football. Since 70 students play football and 30 play both, the number of students who play only football is 40 students. How many students play only basketball? The answer to that question is total basketball players are 55 and 30 of them play both, so there are 25 students. How many students play either football or basketball or both? That will be 40 football players plus 25 basketball players plus 30 who played both, so there are 95 students. And how many students do not play either sports? From 150 students total, there are 55 students do not play football or basketball. We can visualize the set information using a Venn diagram. The left circle represents football players, and the right circle represents basketball players. The overlapping area represents students who play both sports. The area outside both circles shows the 55 students who do not participate in either sports. So the breakdown looks like this: 40 students in only football, left circle not overlapping, 25 students in only basketball, right circle not overlapping, and 30 students in the middle, which is both, and 55 students outside the circles. Now let us move to the probability section. The first question is, what is the probability that a randomly selected students play football? The answer to that question is there are 70 football players out of 450 students, so the probability is 7/15 or 0.467. What is the probability that the students plays both sports? 30 students play both basketball and football, so 1/5 or 0.20. The next question is, what is the probability that a student plays only one sport? We already know that 40 play only football and 35 play only basketball. That is a total of 65 students who play only one sport. So the probability is 65/150, and that is equal to 0.433. The next question is, what is the probability that the students play neither sport? The answer to that question is, we earlier found that 55 students do not play either sport. So the probability is 55/150, and that is equal to 11/30 or 0.367. Are football and basketball mutually exclusive? The answer is no, because some students, specifically 30 of them, play both football and basketball. That means the two events can happen at the same time, so they are not mutually exclusive.
Question 3, number 1, display tray arrangement. For the food fair, the bakery has a special tray that holds 5 mini cakes in a row. The order matters because the most eye-catching spot is at the center. Based on scenario, how many order arrangement of 5 mini cakes can be made from the 12 available flavors? From the question, we know that the counting rules is permutation because of word arrangement, so we are going to use permutation formula. First, n is equal to 12, which is the total number of items, and r is equal to 5, which is the number of items being selected. After that, just use the formula to find the final answer, and we got 95,040. So there are 95,040 ways to arrange orders of 5 mini cakes from 12 available flavors. Number 2, gift box selection. The bakery also wants to prepare gift box with 6 mini cakes each, chosen from the 12 flavors. The order does not matter in this box. How many different combinations of mini cake gift box can be created? For this question, we are going to use combination formula. First, we need to find the number of n and the number of r. N is equal to 12 and r is equal to 6. And then just use calculator to find the answer. The final answer is 924. So there are 924 different combinations of mini cake gift box that can be created. Number 3, special flavor requirement. One of the 12 mini cakes flavors is a limited edition seasonal favorite. The bakery wants to include this flavor in every gift box of 6 cakes. How many different gift box combinations can be formed if the special flavor must be included? For this question, we are going to use combination formula. First, we need to find the number of N and the number of R. N is equal to 11 because one of the 12 flavors is already selected, and R is equal to 5 because one of the 6 slots is already taken for the special flavor. And then just use calculator to find the answer. The final answer is 462. So there are 462 different gift box combinations that can be formed if the special flavor must be included. Number 4, flavor conflict restriction. Among the 12 flavors, 2 are not best and should not be placed together in the same gift box due to allergy concerns. Each box still contains 6 mini cakes. How many different gift boxes can be formed if the 2 not best flavors are never together in the same box? First, we need to find the number of boxes with both not best flavors. N is equal to 10 because the 2 are not best. R is equal to 4 because 2 slots have been taken by the 2 not best flavors. And then just use the combination formula. The answer is 210. So there are 210 boxes that include both nut best flavor together. To find the number of boxes without 2 nut best flavors together is by calculate all the different combination of mini cakes, which is 924 minus with the combination of mini cakes that have 2 nut best flavors together, which is 210. So the final answer is 714. So there are 714 different gift boxes that can be formed if the 2 nut best flavors are never together in the same box.